Hi everyone. Having learned about what all do we understand by a non-parametric test, we're going to move with the first in the series, that is the Kolmogorov-Smirnov test. So this particular test examines if the scores on any particular data that you provide are likely to follow some distribution in some population. So we'll be dealing with the one sample Kolmogorov-Smirnov test for testing if a variable follows normal distribution in a population. So if we're talking about normal distribution, that becomes a Kolmogorov-Smirnov normality test. Otherwise, if you're talking about any other distribution, see, you can check for any distribution really, then that will become that particular test. So Kolmogorov-Smirnov test for normality compares the observed scores versus the expected cumulative relative frequencies. So if you can imagine, it tries to fit a normal curve to the actual data and find out the difference between the fitted and the actual curve. So if that distance is smaller, then it concludes that the distribution is indeed normal. So the null hypothesis of this test is, as always we call the null hypothesis is the hypothesis of equality or ideality. The hypothesis is the data is normally distributed. And the alternative is that data is not normally distributed. So we'll be talking about this data set in which we have reaction times of different variables, R01, R02, and so on. So the question is, which of the reaction time variables are likely to be normally distributed in the population? As a prerequisite, you can look at their histograms with the normal plots also. So to look at the histograms, what you can do, you go to analyze, okay, descriptive stats, and then frequencies. The moment you open frequencies, such a table will pop up. And in this table, pass on the variables on which you are interested in looking at the normal distribution curve. And then we go to charts. I'm interested in the histogram with the normal curve on the histogram. Continue. You can opt out from looking at the frequency tables because I'm just going to have a look at the data. See, I'm just trying to have the feel, on the face of it, how does my data look like? Can I say on the face of it that, okay, these are the variables which appear somewhat to be normally distributed. So when you click OK, you will be able to get this output. So for each of the variables, there will be such a diagram. So this is for variable 1, variable 2, variable 3, 4, and 5. Okay. So as you can see, we all know that the normal distribution is a distribution which has a symmetric distribution such that its skewness is 0, kurtosis is 3, and basically it's a bell-shaped curve. So wherever you see this beautiful bell-shaped curve, we can indeed say that this data might be following normal distribution. So I can see that this variable 1 indeed appears to be approximately normally distributed. Variable 2, nope, it is such a bad shape. Variable 3 is positively skewed, so can't talk about it as well. Variable 4 again gives us some hope, so that also appears to be normally distributed. Variable 5 is again largely positively skewed, so that again does not appear to be normally distributed. So this has sort of given you an idea that variable 4, that is reaction time 4, and reaction time 1 might come out to be normally distributed when you go for a formal test using the Kolmogorov-Smirnov non-parametric test. Now to do this, you go to analyze non-parametric tests, legacy dialogues, and you click on the one sample Kolmogorov-Smirnov test. The moment you are here, you pass on your variables in the test variable list. So which all variables normality you want to test. Then you click on normal distribution here. As I told you, you can check for any distribution, mind it, Poisson, exponential, or uniform. Okay, I'm just doing it for normal. And then in exact, you put it to 5. So this is just this is, I think, a very useless thing. Continue. Options. descriptives, continue, and you click OK. The moment you click OK, you would have this output. So you have a descriptive table and you have finally the test table. Now, when you look at the descriptives, this is just indicative of mean, min, max, and standard deviation. Those are all the usual things. So you might have a glance at it. My interest is in this Kolmogorov-Smirnov test. So for each of my variables, R01, that is reaction time 1, reaction time 2, 3, 4, and 5, I have all of these aspects being worked out. The sample, then the parameters in the normal distribution, mean and standard deviation, most extreme differences. Can you recall? I just told you that the Kolmogorov-Smirnov test tries to find out or tries to fit a normal curve to the frequencies. Now, if that perfectly fits the frequencies, that means that is normally distributed. So what it does, so there is one actual curve and one is the curve which this test is trying to fit. Now, if that difference between these two curves is large, that distance being this most extreme differences. So if that distance is larger, that indicates that the data is far from normal. Okay. So when you look at the absolute difference figures, wherever you see a large number, that particular variable is likely to be not normal. So we see that it is the highest for reaction time 2, followed by 5, and then 3, 1, and then 4. So I think by now also we are having a good idea that, with the lowest ones are 4 and 1. And these were the ones whose histogram also appeared to be normally distributed. So we are going in sync. And then finally you look at the exact significance. So this is the p-value for the null hypothesis testing. So your null hypothesis is test distribution is normal. As you can see here in A part written over here, the null hypothesis is test distribution is normal. And you look at the p-value. If you're able to reject this null, that means your data is not normally distributed. So let me see. 0.164, if you compare it with the level of significance of say 0.05, is way greater. So that means I'm not able to reject the null hypothesis, and hence this particular variable is normally distributed. Then you talk about this p-value of 0, it's less than alpha of 5%. So I can say that the data is not normally distributed as I'm able to reject the null hypothesis. Okay. And then again, here also the same case, 0.042, which is again less than 0.05. I also reject the null hypothesis for this and say that, this is also not normally distributed. And then in the reaction variable 5, again, 0.05 alpha. If we take 0.05 alpha, this 0.002 is less than alpha. So we reject this null of normal distribution. In the fourth variable, p-value is 5%. So this 0.733 is way greater than than the alpha of 5%. So we are not able to reject the null now, and therefore the reaction time trial 4 variable is also normally distributed. So the results are indeed in sync with what we saw visually. As I said, sometimes it pays you by looking at the data. Thank you for watching the video.